Hello, welcome back. This is mechanics, motion in 1D. So let's look at example 2. So in the last video we looked at example 1 on how you can answer questions, right? In motion in 1D. So let's just look at example 2, which is a free fall example. So it says that a heavy rock is dropped from rest at the top of a cliff and falls 100 meters before hitting the ground. How long does it take to fall to the ground, and what is the velocity when it hits the ground, right? So let's just zoom in to our diagram here, right? So let's do this. So now we're in the y direction. We can just replace the x from previous example to with y's, right? So here, what do we have? We have y0, we have v0, we have t0, right? And here we'll have what we will have y1, v1, t1. Let's choose a direction. Since it's been dropped, we can just choose this direction that moves in as our positive, right? Take downward direction as positive. You can write that down, or you can even indicate it on your diagram, right? So yeah, I like this. So let me just write it much better. Okay, positive. So let's just write what we're given. Okay, let's just push this here. What are given? It starts at 0, so we know that. So let's just start with y. We know this is 100 meters, right? Oh, we can just say that's 0. That's where we start, right? Okay, what can we do? Should we take this as 100 or this as 100? So since we start here, right, and we took this as our positive direction, so everything increases in this direction, right? So let's just take that as 0 meter, even though it's at a height of 100, right? And then the initial velocity, let's take that as 0 meters per second because we started rest, it was dropped. And then t0, that's our 0 second. And then y1 is 100 meters, and then v1, we do not know what that is. That's final velocity. In free fall, we know that we have a constant acceleration, right, which is due to gravity. So this will have y1 is equal to, since we're taking positive downward as positive, it will be positive. So it's 9.81. It's 9.81. Some people use 9.8, but I prefer 9.81. It's much more accurate this way, right? So we have all of this, what we need, and also what we are given, right? So the question was to ask us to calculate how long does it take to fall, right? So we want to find t1, or the change in t, and what is the velocity when it hits. So which one can you start with? We can start with the time. So we're given the initial velocity, we know this. So we have a lot of things that we're given actually. So we're flexible in what we can choose. So let's see, what can we choose? We want to choose the equations. Let me just look at our equations of motion. So we can select an equation, right? So let's just select this one, where we have final displacement of final position is equal to initial position plus what? Plus the initial velocity, change in time, plus 1 over 2 a1 change in time squared, right? So we know what this is. That's 100, and then we have 0 plus this will give you 0 by changing t, because we're looking for changing t, 1 over 2 multiplied by 9.81, right? multiplied by changing t squared. So when you do it very well, even your signs will check out. You won't have problems with your signs. Everything will be positive if it needs to be positive, right? So we know that our time is always positive, so we expect a positive answer, right? So let's see, 0.5 multiplied by 9.81, that's 4.905. Let's take it as that. T squared, let's divide by 4.905, so 900 divided by that, change in t. So let's just to be very accurate with our answers, let's just take this as our fraction, right, before we find the answer. And then let's take a square root on both sides. So our square root will be plus or minus, but since this is time, we won't consider the negative option. We'll only take the positive option, right? Therefore, change in t is equal to, so answer, this is 4.5152. So I'll just take 4 point, let me just, or from now on when I have a 5, it doesn't matter which one is following it, I'll just take it, I'll just round up, right? If I wanted to be too accurate, I can just take 5.51 because the 5 is followed by 2, so we have something like 5152. This is an even number, it's less than 5. I can just round this one and just leave it as 51, but let's just leave it, let's just say 52, right? 52 seconds. If you're confused by that, don't worry too much about it. Do what you know to do, right? That's just how I do things. Don't worry about it. So this is with 5. Let me just write it much better so you see. 5.2 seconds, right? So this is the time it takes for your the time it takes for the rock to hit the ground, right? So now we want to find the final velocity. How can we find the final velocity? We can just use the other formula where you have v. So since we're using v1 and v0, so you have v1 is equal to v0 plus ax change in t. So we have v1 is equal to 0 plus 9.81 multiplied by 4.52. Therefore, v1 is equal to, so let's say 9.81 multiplied by 4.52, that gives us what? 44.34. 44.34 meters per second, right? Downwards. Let's not forget our direction. Or instead of putting downwards, you can just put a plus sign here, right in front of the answer. But it's better to write your direction as downwards because you've already indicated the side that downward is positive. So let's just get a recap on what we did. Let's see. With our question, they gave us 100 meters. It was a rock that was dropped from rest. So we know that the distance from that side to here was 100 meters. We wanted to find the velocity here, the final velocity at the end. What was it? And what was the change in time? Okay, how long did it take for the rock to be dropped from here and then fall to the bottom here, right? And then we just used our equations of motions, the ones that were appropriate to you, simple, straight to the point, right? The correct ones actually. And then we had the final position equal to initial position. So this is what we have seen before, just that now we have y instead of x, right? We know our acceleration is always 9.81 downwards for objects in freeform, right? Some people use 9.80, right? Not 9.81. It's fine. It depends on what your tutor, sorry, your teacher or lecturer prefers, right? If they say use 9.8, use 9.8, right? I'm using 9.81 because of what I'm used to. I'm used to using 9.81, but back in high school, I used to use 9.80, right? Because it didn't matter that much. So we found our the time as 4.5 seconds to hit the ground, and then we have 44.34 meters per second. That's very fast for a long drop from 100 meters. It makes sense though. It makes sense. So yeah, that's what we had for our questions for example 2. So next time we'll be looking at motion graphs, right? How do you draw these displacements and time graphs, and what do they mean? What does the shape mean, right? And also, we talked about the relationship between velocity, displacement, and acceleration. How do you indicate that on a graph, right? How do you capture all of this data on a graph, and then you can just read it from a graph, right? So that's a very, very important aspect of motion. So we'll be looking at that on the next video. Don't miss out. Thank you. Until next time.